Hi, so this is a graph that you need to be doing for your activity 2 for the ideal gas law constant. It says using a computer graphing program, create an XY scatter plot of the moles of oxygen versus the volume of gas generated. So what I have here is I have the moles of oxygen and the volume of gas. Basically, your moles of oxygen is something that you will calculate using the stoic from the using the moles of peroxide, and those are going to go on the x-axis. And then the volume of gas is something also you will calculate during the experiment. You'll sort of measure during the experiment, and that you will have it in mils, and you need to convert that into liters. And that volume of gas will go on the y-axis. Once you have your data set, let's go ahead and highlight this. And then I go into insert here, and it says to plot a scatter plot. Basically, the scatter plot shows relationship between variables, relationship among different variables. So I'm going to click this and then take a look at that. Here's your scatter plot. While you're in here, notice chart design pops up. Go into add chart element, axis title, and then primary horizontal. Let's delete that, and then you can put down here moles of O2. Same thing, let's go in here and do the axis title for the primary vertical. And for that also, I'm just gonna do this and volume of gas. And right here you can make the title moles of O2 versus volume of gas. And then basically what you can do is you can minimize this too like that. Okay. The next thing it says is create a best fit line on your graph, set the y-intercept equal to 0, and display the equation of the graph. First thing, the trend line. Okay, so set your data point or your cursor on any of these data points, and then click on the right click. Notice it says add trend line. Let's do that. And notice when I choose, it says set intercept to 0. When I choose set intercept, watch what happens to this line here. The line moves. Basically, what's happening is the regression line moves in such a way so that it's it's basically averaging the x's and the y's on the line and forcing the line to go through 0, and that's called the force intercept. And then we need to display the equation. And here's our equation. And this equation has your slope. Okay. Remember, the slope is calculated y equal mx plus b, or y2 minus, using that equation, m is going to be your slope, or you can do y2 minus y1 over x2 minus x1. Okay. So let me make this, change the size on this thing to at least 14 so that I can read the number. And that's your y-intercept, your m right here. You are going to use this. M is 21.935. And one of the things it tells you for the R gas constant is to use this formula, and m is the slope that we just found here, 21.935. And you know the slope is y2 minus y1, so you will have your liters up here, and then x-axis is moles a mole at the bottom, times pressure is 1 atmosphere over T, which is something you calculated using the thermometer, or you measured during the thermometer, and you measured it in Celsius. You just need to convert it into Kelvin. And so basically you add the, to find T Kelvin, you do T Celsius plus 273.15. And so for me, it's going to be 293.15. And this, when I solve, I get 0.0747 ATM over mole